Okay. So let's take a look at this graph. And I'm going to ask the limit of this function from the left-hand side of 0. The limit of this function from the left-hand side of 0. Anyone?
1.
Yes. As x approaches 0 from the left, the function values get closer and closer, closer and closer to 1. Do you all see this?
Yes.
What about from the other side? As x approaches 0 from the right?
-1.
-1. Because when x approaches 0 from the right-hand side, the function values get closer and closer, closer and closer to -1. Good. This is not the example that we had. That's why I chose that. Now, finally, what will I say? And I'm going to write this down and stop for a moment. So we had limit of f of x as x approaches 0 from the left, and you said 1 perfectly. The limit as x approaches 0 from the right of f of x, and you said -1 perfectly. And now I'm going to stop, and I'm going to ask, what do you think is the limit? Which page am I on? I want to make sure that I keep them straight. F of x as x approaches 0 from either side. Careful. Before you say anything, let me show this. This side is here, and this side is here.
It does not exist.
Exactly. They must be the same. Excellent. So this limit exists, and this one exists because both sides approach the same number. So the left-hand side is 1, but the right-hand side is not the same. They're not the same. They both exist, but they're not the same. So then the limit from either side is DNE. DNE stands for it does not exist. Awesome. Now I'm going to ask another question here. What about f of 0? Can anyone give us f of 0? So we can write f of 0 here.
1.
Excellent. Good. Now let's also look at 2. Can anyone tell us what is the limit of the left of 2? I'm going to write it. Limit as x approaches 2 from the left, and the limit as x approaches 2 from the right. And which problem was this? Problem 6. Okay, so this was number 6 in 2.2. Okay, so can anyone give us the limit of this function from the left of 2? As x approaches 2 from the left, the function values get closer and closer, closer and closer to
2.
Exactly. What about the other side?
2.
Awesome. Now I'm going to stop for a moment. What do we conclude about the limit of f of x as x approaches 2 from either side?
The same.
Exactly. Not the same. It's 2. What about f of 2?
Does not exist.
Very good. So here's a very important remark. This again talks about trend, not function value. Not function value. So what I mean by that is, if a function is like this one, continuous, but the left-hand side and the right-hand side approach the same number, it's continuous, then the limit exists. What about this situation? Still exists. Why? Because the trend from the left and the trend from the right approach. Approach does not mean equal. We don't care what happens here. We are only interested in the trend, not the function value at that point. So the function still has a limit, even if it's not defined at that point. Now, there is something that I want to explain with an example, maybe two examples. You mentioned a while back, a few minutes ago, vertical asymptotes. So let's say x equals 4 and x equals 4. Now, I may have this situation of a function, or I may have this situation. So let's analyze this for a moment. Limit as x approaches 4 from the left for this one, and then limit as x approaches 4 from the right of this function. What is the limit from the left? So as x approaches 4 from the left, the function values get closer and closer, closer and closer, closer and closer to
Infinity.
Awesome. What about on the other side? As x approaches 4 from the right, the function values get closer and closer, closer and closer to
Infinity.
Good. What will be for this function the limit from either side?
Infinity.
Good. However, I'm not going to write it. It's still DNE. But I have to write infinity. So I'll come back to this for a moment, in a moment. So allow me to write one thing here. The limit exists only if it is a number, not infinity. But in this situation, I have to write infinity, keeping in mind it still does not exist. It does not. It's not a number. Infinity is not a number. It's a symbol. So in the back of my mind, I know it does not exist, but I have to write infinity. What about here? What is the limit as x approaches 4 from either side?
Negative infinity.
From either side, directly. We jumped. We jumped directly to either side.
Isn't it positive infinity and the other one's a negative infinity?
Yes, and from the other side, from either side.
Does not exist.
Exactly.
Oh, it does not exist. Okay.
Exactly. Perfect. We jumped. We did not make the same analysis. Yes, indeed. It's negative infinity from the left and it's positive infinity from the right. This is definitely DNE. This is also DNE, but I have to write infinity. Okay, back to our graph. Okay. Let's see. I think let's choose, for example, here. Let's say the limit from the left of 2. What is the limit from the left of 2?
Negative infinity.
Perfect. What is the limit from the right of 2?
Positive infinity.
Perfect. What is the limit from either side of 2?
Does not exist.
Does not exist, indeed. Okay. So let's take a look at other situations. I would like to create something like this. Let's choose something like this. We are given 15, 16, 17, 18. This is a good practice for understanding what we just discussed. So let's choose a problem from here in which we are asked to graph an example. So there are multiple correct answers here. To graph an example of a function that satisfies the given conditions. Okay, let's look at 17. I'm going to copy the whole thing. So I have limit as x approaches -1 from the left of f of x is 0. Limit as x approaches -1 from the right of f of x is 1. Limit of f of x as x approaches 2 is 3. F of -1 is 2, and f of 2 is 1. And then hopefully we have time to look at a piecewise defined function again and identify, or maybe not, maybe we already have this. I'm jumping back for a moment. Looking at this, we don't even have the graph, we don't care for the graph. Can anyone from my table tell us the limit of this function as x approaches 0 from the left? As x approaches 0 from the left, what is the limit of this function?
-1.
Of course.
-1, yeah.
Of course. And the limit from the right-hand side as x approaches 0 from the right?
1.
Of course. And what is the limit from either side?
DNA.
Of course.
DNA.
That's why this table is gold. I will not take credit for it. Somebody else showed it to me 100 years ago. So it's very clear now. The limit from the left is -1. The limit from the right is 1. The function value is -1. And the limit from either side is DNA. Good. Where am I here? Now, this for me is gibberish. Foreign language. I don't understand a thing. And now I want to show you how this will become a piece of cake. So I have 5 conditions. I'm given a limit, another limit, 3 limits, and 2 function values. I will start by identifying domain. Okay. I'll start with f of -1 is 2. Don't cross it out like that. I just want to make a point. I'll continue with f of 2 equals 1. Then at 2, from either side, limit of f of x as x approaches 2 from either side is 3. Limit from the right hand side of limit of the f of x when x approaches -1 from the right is 1. The limit of f of x as x approaches -1 from the left is 0. Okay. So now I know exactly what I need to do to show an example of such a function. You can fill in anything else you want, but these conditions have to be fulfilled. Of course, I'm going to start with the points -1, 2, and 2, 1. Then the limit from the left-hand side of -1 is 0. The limit from the right-hand side of -1 is 1. But I have to be careful. I can put a vertical asymptote if I want to, but I leave it alone for a moment. Let's see on this side. So 2, 1, and then the other side, 3. Again, the points are here, -1, 2, and 2, 1. Limit from the left is 0. Limit from the right is 1. Limit from either side is 3. This is my example of a function that fulfills all the given conditions. You can add whatever you want to it. You can put a vertical asymptote here and go into infinity here, whatever else you want. There are infinitely many correct answers. Any questions on this? Okay, I want to talk about something called, yes, go ahead.
Hey, so your function that goes out to negative infinity, that's just infinity, I mean, correct?
You mean here?
Yes, okay, never mind, it is.
Yeah, you can make it go into infinity. You can make it.
I was looking at its whatchamacallit form, and yeah, never mind, you got it.
You can add on whatever else you want. Okay, so we do have two different types of limit that involve infinity. Limits at infinity and infinite limits. This is for later. This is for now. Meaning the answer is infinity. Here is an example. Limit as x approaches infinity of f of x. Limits at infinity. This one is when the answer of a limit of f of x as x approaches a is positive or negative infinity. So let's graph a very simple function that I would like you to remember always. This is a rational function, 1 over x. We learned about everything about this function a long time ago. And here it is. And this is function 1 over x. Please remember it forever. Oh, 1 second, I need to